Hello everyone, my name is Akash Mohammed, and today I'm going to be discussing how can an engineer choose the most suitable distillation internals. My presentation and my report focus on comparing tray columns and structured packing for the separation of propylene and propane in the petrochemical industry. Moving on, propylene is one of the most important raw materials used to manufacture plastics, fibers, and many petrochemical products. However, separating propylene from propane is extremely difficult as they both have very similar physical properties and low relative volatility. According to the Aspen HYSYS simulation discussed in my report and as seen in my presentation slide, um, achieving 99.2% mole percent propylene required a distillation column with 148 trays and a height of an approximate 67 meters. This creates a significant pressure drop and increases the reboiler duty, making the process one of the most energy intensive separation in the industry. Therefore, engineers continue to investigate whether tray column or structured packing provide better performance. Into the literature, it shows that both tray columns and packed columns achieve vapor-liquid contact differently. In the tray column, the liquid flows across horizontal trays, while vapor rises through. In contrast, structured packing allows the liquid to flow as a thin film over the packing surface, while vapor travels upward through open channels. Sorry. Krishnamurthy and co-workers improved the efficiency of tray columns by installing VG plus valve trays, whereas Skulls showed that Raschin super rings could reduce pressure drop by more than 50% while maintaining good mass transfer performance. My engineering analysis compared the pressure drop of both systems for the tray column. For the tray column, the pressure drop increased. Sorry, again. My engineering analysis compared the pressure drop of both systems for the tray column. The pressure drop increased from 4.02 to 4.45 millibar per tray after the installation of VG plus trays. This corresponds to an increase of an approximate 10.7%, although the pressure drop became slightly higher. It improved vapor-liquid contact significantly, enhancing separation efficiency. On the other hand, for the packed column, Skulls reported that the Raschin super ring reduced pressure drop by approximately 62%, compared to conventional packing, meaning vapor flows much more easy through the column. I also compared the overall performance of each design using the efficiency equation presented in my report. The tray column achieved an improvement of an approximate 58.3% after the revamp. The packed column does not report efficiency in the same way, so I used pressure drop reduction as the performance indicator. The packed column achieved a 62% reduction in pressure drop while maintaining excellent mass transfer characteristics. These calculations show that tray columns maximizes separations efficiency, whereas packed columns maximizes hydraulic efficiency. My results indicate that there is no universal superior distillation internal. Tray columns provide much better separation efficiency after their revamp, making them suitable while achieving very high product purity is the priority. On the other hand, structured packing significantly reduces pressure drop and energy consumption, making it more suitable when reducing operating costs is the main objective. Therefore, engineers should choose the column internals based on the specific requirements of the process rather than assuming one design is always better than the other. Moving on to sustainability. Improving distillation eternals also requires sustainability. Lower pressure jobs mean less energy is required to operate the reboiler. Supporting UNSDG 7. Revamp exiting columns instead of constructing new ones supports UNSDG 9, and higher propylene recovery reduces waste, supporting UNSDG 12. And finally, emerging technologies such as ionic liquid extractive distillation, membrane separation, and vapor recompression could further reduce greenhouse gas emissions, supporting UNSDG 13. Last but not least, moving to the reflection. Through this investigation, I developed a much deeper understanding of mass transfer and separation processes. Before starting the project, I believed that selecting the best distillation internal mainly depended on separation efficiency. However, I learned that engineers must always and also consider pressure drop, energy consumption, operating capacity, and sustainability. This investigation strengthened my understanding of how engineering principles are applied when designing industrial separation systems. Thank you so much.